In the dark beyond Neptune, sunlight loses its warmth and becomes arithmetic. Each ray is a calculation, distance divided by fading. Here, heat is memory, not presence. Most comets that dwell in this region circle the Sun slowly, repeating paths carved billions of years ago. But early in 2025, telescopes in Hawaii saw something that did not belong. The Asteroid Terrestrial Impact Last Alert System, ATLAS, records the night sky in sequences of digital frames. A routine subtraction revealed a moving point, faint and slow. Software marked it for review. Technicians compared images, corrected distortion, and measured motion. Within minutes, the object's path refused to close. Every comet ever catalogued obeys an ellipse. This one described an open curve, a hyperbola. Such geometry means escape, a trajectory that enters and never returns. When astronomers solved for its velocity, the result exceeded every bound orbit. It was approaching from the direction of Lyra at 88,000 kilometers per hour, enough to cross the Earth-Moon distance in 5 hours. On February 2nd, the International Astronomical Union issued a designation, 30I Atlas. The number marks it as the third interstellar object ever observed. The letter I means interstellar. Atlas honours the survey that caught it. At first it looked ordinary, magnitude 21, smaller than a pixel on most screens. But over the following weeks its brightness increased. As it crossed Saturn's orbit, instruments detected a coma, a thin halo of gas. That should have been impossible. At 5 astronomical units from the Sun, the temperature is 170 degrees Celsius. Water there should remain ice, locked and silent. Yet 3I Atlas began to breathe. Spectra from Mauna Kea showed emission lines of H2O and CO2. Analysis suggested 40 kilograms of water per second leaving the surface. It was as if a frozen mountain had turned into a pressurized fountain. The James Webb Space Telescope joined the campaign in August 2025. Its ENIA-spec instrument recorded a broad plume, rich in CO2 and dust. The ratio of CO2 to H2O was reversed compared with local comets. The chemistry was alien. Scientists checked everything that could be wrong. Calibration, pointing, scattered light, detector noise. Nothing erased the signal. Water vapor streamed from a comet too cold to melt. Hubble confirmed a greenish coma, the color of ionized carbon. Ground observatories mapped the tail stretching millions of kilometers. The media adopted a name that researchers disliked but never escaped, the cosmic firehose. Inside observatories, disbelief mixed with quiet joy. Something was challenging the textbook. Solar heat could not explain it. Radioactive decay required impossible isotopes. Tidal stress from Jupiter was too weak. One proposal seemed plausible, the crystallization of amorphous ice. Amorphous ice traps gas within its structure. When warmed, it snaps into a crystal lattice and releases the gas in sudden bursts. Million tiny vents could produce a steady jet, but to maintain 40 kilograms per second for weeks would demand energy the Sun could not supply at that distance. By June 2025, the orbit was fixed, inclination 43 degrees, perihelion 2.1 astronomical units, outbound path toward Crux. No planet could capture it. No star would see it again for millennia. Its nucleus appeared small, perhaps 5 kilometers wide, with a density less than half that of water. Rotation period, 9 hours. Every turn brought pulses in brightness like a slow heartbeat. Spectra revealed traces of nickel and sodium, elements rare in solar system comets. Those signatures hinted at a birth near a hotter star, then ejection by gravitational chaos. For billions of years it had drifted through interstellar dust, its surface darkened, its interior preserved. Now it was crossing the Sun's domain for the first and only time. Observatories across the world synchronized their schedules. The European Southern Observatory allocated nights for polarimetry. The Atacama Array searched for organic molecules. NASA's JWST logged every spectral change. Even ESA's Mars Express orbiter captured distant images as the comet passed near Mars's orbit. Each dataset told the same story. 3I Atlas was active where no comet should be. In Pasadena, JPL analysts ran backward simulations through Gaia's stellar database. Possible origin: a binary system in Lyra, about 60 light-years away. estimated departure time, 7 billion years ago. If true, the comet left its home before Earth had oceans. It spent those ages between stars, collecting dust, enduring radiation, eroding atom by atom, and yet it remained whole enough to shine. Amateur astronomers began to track it with backyard telescopes. Long exposure photos revealed a thin green tail cutting across Capricornus. They posted images online, adding labels of awe rather than science. The public glanced and moved on, but the quiet watchers understood the scale of what they were seeing. A piece of another sun's history was passing through our sky. At the European Southern Observatory, a researcher noted in her log, "Still active, still impossible, still beautiful." The sentence travelled across forums and articles because it sounded like a summary of the human condition. 3. I-Atlas kept moving, steady and silent. Every rotation spun its frozen vents toward a sun that could barely touch them. Every pulse of gas was a breath from another epoch. For scientists, it became a reminder that the universe does not obey our expectations. For everyone else, it was a story of motion through emptiness, a visitor that should have been dead but wasn't. The firehose in the dark continued to flow, its tail glowing green against the black. It would cross the inner system only once. When it departed, its trail of vapour would stretch for millions of kilometres before vanishing into the solar wind. And for a brief season in 2025, our species watched. It happened. No messages, no warnings, no drama. Only an object that refused to stay frozen. Every new object in astronomy begins as data. Coordinates, brightness, velocity. Yet within those numbers lie possibilities large enough to shift how we understand creation itself. 3. I-Atlas entered that conversation the moment its orbit was confirmed. The first comparison was inevitable. Observers remembered 1 Oumuamua, the cigar-shaped fragment that passed through in 2017, dry and silent. It reflected light, but emitted nothing, tumbling without a tail. Some called it a shard of rock, others a fragment of something manufactured. Then came Tugursh and Borisov in 2019, active and dusty like comets from our own system. Now, 6 years later, 3 I-Atlas appeared to combine both stories, familiar in form yet alien in behaviour. At 5 astronomical units, water should be frozen harder than stone. Carbon monoxide and carbon dioxide might sublimate faintly, but never at 40 kilograms per second. Thermal models built for solar system comets failed when applied to this data. Temperatures, exposure times, energy flux. None could drive the venting that telescopes recorded. Teams across the world began to test alternative explanations. One suggestion: internal crystallization. Amorphous ice, when warmed, reorganizes its structure and expels trapped gas. In laboratory conditions, this process releases enough pressure to lift grains of dust. Scaled to a comet 5 kilometers wide, it could, in theory, generate a plume. But 3 I-Atlas showed no bursts, only continuous flow. Its activity was too stable. Another hypothesis pointed to buried pockets of volatile material, perhaps oxygen, nitrogen, or methane frozen in cavities. Micrometeorite impacts during its billion-year journey might have fractured the crust, exposing deeper layers that still retained energy. If sunlight reached those fractures, venting would follow. Yet models predicted such exposure would be brief. The fractures would seal under a frozen frost. The comet, however, kept breathing month after month. A third idea was far more speculative, that the comet carried residual internal heat from radioactive isotopes formed in its parent star's protoplanetary disk. Even minute traces of aluminium-26 or iron-60 could produce measurable warmth over millions of years. No direct evidence supports this, but neither can it be dismissed entirely. Each new measurement added confusion. Spectra showed a dominance of CO2 over H2O, the reverse of every known solar system comet. This ratio suggests formation far colder than our own Kuiper belt. Somewhere in another system's outer disk, carbon dioxide may have frozen first, trapping water beneath. When the comet was thrown into interstellar space, that inverted layering froze the anomaly we see today. Microwave observations hinted at complex organics, faint signatures of methanol and acetylene. Those molecules form in deep cold under ultraviolet radiation, Their presence implies that chemical evolution happens even between stars, in objects wandering alone for billions of years. Hubble's photometry revealed that the nucleus rotated once every 9 hours. Each rotation changed brightness by about 15%, meaning the shape is irregular. Perhaps two lobes, like a contact binary similar to Comet 67P. If true, rotational stress could periodically open and close fissures, pumping gas in rhythm. Astronomers at the European Space Agency modelled that effect and found it plausible. The pattern fits the observed 9-hour cycle. When the sunlit side turns away, emission falls. When it faces the sun again, water spikes, a mechanical heartbeat. Comparisons to previous interstellar visitors deepened the sense of uniqueness. Oumuamua was rocky, small and dry. Borisov was icy, active, and short-lived. 3. Atlas is icy but active beyond reason, durable and slow to fade. Where Oumuamua offered mystery through silence, Atlas offers mystery through excess. One refuses to speak, the other shouts. When the JWST spectra were published, the numbers startled even veteran researchers. CO2 emission lines were nearly twice as strong as those of H2O. Dust-to-gas ratio, unusually low. That combination hints at fine particles suspended in steady flow rather than explosive jets. The plume seems smooth, almost laminar, as if driven by uniform surface heating rather than sporadic vents. The Atacama Array contributed microwave data revealing the same rhythm. The plume brightens and dims every 9 hours. Rotation again, predictable, persistent, patient. By late 2025, 3I Atlas had passed inside Jupiter's orbit. Its tail stretched millions of kilometers, bifurcated into a faint secondary stream. Some interpreted this as fragmentation, others as a secondary vent. No large debris was seen, suggesting structural integrity despite stress. At conferences in Prague and Pasadena, researchers debated language. Was it correct to call it a comet at all? Some preferred active interstellar body. Others clung to the familiar term, arguing that behaviour defines the class, not origin. Through every debate ran a quieter theme: humility. We have catalogued comets for centuries, yet a single visitor from another system can overturn our rules in weeks. For the public, the story became a distant wonder. For astronomers, it became a case study in how ignorance persists at every frontier. One researcher described the feeling succinctly. We are watching chemistry from another star system unfold under our sun. That line circulated through scientific blogs and interviews, summarizing the astonishment behind the numbers. At observatories in Chile and Spain, night crews spoke softly as they watched real-time displays. On those screens, 3I Atlas moved barely a pixel per hour. In its slowness lay scale. The object's apparent stillness reminded everyone that speed depends on perspective. At 88,000 kilometers per hour, it crossed interplanetary space effortlessly, while in the eyepiece it seemed almost still. Sometimes a field technician would pause the tracking feed just to see the comet drift. A faint dot sliding through static. Every photon in that dot had travelled hours from the far edge of the solar system, bouncing off ice that left its home before life existed here. The most precise orbit models predict that 3I Atlas will reach perihelion in mid-2026. It will never come closer than twice Earth's distance from the Sun. After that, it will fade toward the southern constellations, its trajectory slowly curving toward interstellar night. By 2030, it will be beyond detection. We will never send a probe. No spacecraft travels fast enough to catch it. The record of its visit will remain in databases, papers, and a few terabytes of raw spectra. In that data lies a message we may study for decades, a demonstration that nature remains more inventive than our theories. 3I Atlas is teaching us that ice can behave like fire, that emptiness still holds motion, and that the laws we trust are flexible at the edges. The object continues to drift, patient, precise, and indifferent. Our instruments follow, knowing this is the only time they will ever see such a thing. The data continued to arrive, line after line, night after night. Astronomers compared readings, corrected for noise, recalibrated instruments, and still the signal held. The comet refused to fade. Every measure of its activity contradicted expectation. Yet over time, the disbelief turned to quiet acceptance. If an object from another sun wanted to rewrite the limits of physics, humanity would record it, not argue with it. In academic circles, the discovery became an anchor for renewed interest in interstellar chemistry. Papers on crystallization, sublimation, and volatile retention surged. Some speculated that objects like 3I Atlas might be common, their visits simply rare alignments of geometry and luck. Others thought the comet represented a transitional class, too active to be inert rock, too distant to be typical ice. Definitions blurred. The blur invited imagination. Beyond laboratories and universities, the public started to notice. Social media filled with images taken through small backyard telescopes. Most of them were noise, blurred dots, streaks of green, but to those who took them, the images meant proximity to something beyond human history. People began calling it the Stranger, a name that spread faster than the scientific one. Journalists liked the metaphor. Artists painted versions of it crossing unfamiliar skies, and someone even produced a simulation that mapped its passage in real time. For a few months, an object 80 times smaller than New York became a minor symbol of cosmic perspective. Scientists kept their tone measured. They preferred facts to feelings. They repeated that 3I Atlas was a natural phenomenon, nothing mysterious, only misunderstood. Yet between the lines of their reports, traces of wonder appeared. Still active, one log read, still impossible. That phrase became shorthand among the observing teams. It carried both exhaustion and pride. Observation after observation produced the same conclusion. The universe remained unpredictable. Inside observatories, coffee cooled next to monitors showing graphs of gas output and rotation phase. Outside, amateurs stared at dark skies, hoping to see a comet invisible to the naked eye. A few succeeded. Under clear air, the green coma glowed faintly, a soft breath against black. The light carried no message, yet to those who saw it, it felt like one. In that feeling lay something science cannot quantify. The recognition of motion through vastness, a reminder that not all travel is purpose, some is persistence. Journalists eventually moved on. News cycles need novelty, and space, though grand, moves slowly. But in academic circles, the fascination deepened. Teams began to simulate the comet's origin, tracing its path back through galactic coordinates. A probable source emerged, a binary star where gravitational instability might eject bodies into space. If that model is correct, 3I Atlas began as dust in a protoplanetary disk long before the Sun existed. It drifted in darkness for 7 billion years before crossing our system by chance. Such timelines exceed imagination, yet they are factual, measurable, written in isotopes and spectra. To study them is to realize that time itself is less a line than a sea, and that humanity occupies a shallow shore. Students asked their professors what it means to witness such a visitor. The answers were cautious. It means the galaxy is not empty. It means materials travel. It means our instruments are finally good enough to see the improbable. But under those statements ran quieter truths. To look at 3I Atlas is to confront distance and survival. It is to see endurance without intent. A frozen body still breathing after billions of years, shedding itself grain by grain, yet continuing forward. The idea that such a thing exists at all is its own lesson. It tells us that persistence does not require awareness. It happens simply because physics allows it. That lesson resonated beyond science. Writers, philosophers, and even political commentators invoked the comet as a metaphor for resilience. Some called it a symbol of patience, others of futility. For astronomers, it was neither. It was a reminder of scale. Against that scale, human debates shrink to noise. The object will continue to move long after every discussion about it ends. The simplicity of that truth gave a sense of peace. People who watched it through telescopes described the same reaction, a calm that came from recognizing how little depends on human witness. If the comet had passed unseen, it would still have breathed its plume, still have traced the same path. We are incidental, yet included. That quiet coexistence between insignificance and inclusion is what gives astronomy its depth. As months passed, 3I Atlas began to fade from public attention but not from the sky. Its magnitude remained steady enough for instruments to record data. Each observation added to the long chain of human curiosity stretching from Galileo to the present. In conference presentations, slides of its light curve appeared like heartbeats on a monitor. Steady, patient, indifferent. One scientist closed a talk by saying, "We will never know its destination, only that it had one." The room was silent afterward, because nothing more could be added. The comet did not need purpose. It already had motion. In its unplanned visit, humanity glimpsed its own reflection. Brief, curious, persistent, and temporary. The stranger from another sun moved on, and the watchers continued to look up. By the start of 2026, 3i Atlas had crossed the orbit of Mars. Its distance from the Sun was shrinking, though by any human measure it remained unimaginably far. Instruments registered subtle changes in brightness. The green coma thickened, the tail widened, and for a brief time the comet became one of the faintest objects ever tracked simultaneously by telescopes on Earth and in space. Each new observation deepened the puzzle. The water plume continued at nearly the same rate even as sunlight increased. If heat were the driving force, the venting should have surged exponentially. It did not. Instead, the output held steady. This was not melting, it was something else. At the Atacama Observatory, teams analysed the ratios of carbon dioxide, carbon monoxide, and water. They found variations that suggested layering inside the nucleus, strata of ice mixed with fine dust, perhaps compacted by impacts during its early life. The chemical structure was not chaotic but patterned, like rings in ancient wood. If that interpretation is true, 3i Atlas may preserve a record of conditions inside its birth disk, a snapshot of another solar system frozen in place. The European Southern Observatory confirmed a change in rotation period, from 9 hours to about 10. The deceleration hinted at mass loss through asymmetric jets. As water and dust escaped, momentum shifted, slowing the spin by fractions of a second each day. It was the most delicate example of cause and effect ever recorded across interstellar distance, a breath altering a body's rhythm. Meanwhile, amateur astronomers noticed a secondary tail forming behind the main one. Images taken over successive nights revealed a faint filament curving away from the sun. In time-lapse sequences, it looked like a thread unspooling. Models later showed that this structure was likely composed of heavier dust grains ejected during brief outbursts. Yet the timing did not match any change in solar wind or radiation pressure. The trigger came from within. This internal rhythm fascinated researchers. They began to treat the comet less as an anomaly and more as a system, a more dynamic, evolving object whose rules we simply did not yet know. Theories multiplied. Some spoke of microfractures sealing and reopening under alternating stress. Others suggested thermal lag, sunlight penetrating porous layers, heating gas pockets that vented hours later on the comet's night side. Every hypothesis was both elegant and incomplete. The truth, as often, was likely a combination of them all. In February 2026, JWST captured the comet in mid-rotation. Its NIRCam images revealed complex shadowing in the coma, perhaps indicating multiple vents. The brightness curve looked like the pulse of a living thing. Scientists did not say that aloud, but the resemblance was difficult to ignore. As the data accumulated, the sense of intimacy grew. For more than a year, 3i Atlas had been a constant presence in astronomical news feeds. Researchers spoke of it the way sailors once spoke of stars, steady companions, distant yet reliable. But by March the pattern began to change. The water signal weakened slightly. CO2 emissions fluctuated more erratically. The symmetry of the tail broke apart. Fragmentation was likely beginning. Hubble's images from April showed faint debris arcs trailing the main nucleus, fragments no larger than houses but bright enough to scatter sunlight. The comet was not collapsing but shedding. It was aging visibly, a process usually hidden across centuries, now unfolding in weeks. For scientists, the disintegration was a gift. Each fragment exposed new material, fresh ice untouched by cosmic radiation. Spectra from these regions showed an abundance of simple molecules, formaldehyde, ammonia, methane, all signs of primitive chemistry. Such materials are the starting points of organic evolution. To find them preserved inside an interstellar visitor was to glimpse conditions older than Earth itself. The press returned briefly, though the headlines were smaller this time. There was no drama in slow decay. Yet for those who followed closely, these were the most meaningful days. They were watching not a mystery, but a revelation of structure, At a conference in Geneva, an astronomer presented a slide showing the nucleus surrounded by its expanding cloud of fragments. "This is what survival looks like," she said. "Not permanence, but persistence through change." The room was silent afterward, not from awe, but recognition. Everyone present understood that description applied to more than comets. Through spring, 3 of the Atlas continued its inward path, nearing perihelion. Instruments recorded a final rise in brightness. Its tail reached maximum length, tens of millions of kilometers of dust reflecting sunlight that would never touch another surface. For a moment it was at its most visible, a narrow scar across the black. When it passed closest to the sun, something unexpected happened again. The water plume diminished only slightly. Instead of bursting into violent activity, the comet steadied, as if stabilizing under the greater heat. Thermal models failed again. The material inside it was responding to physics we barely understood. A few scientists began using the phrase adaptive venting, not because they believed the comet was self-regulating, but because the pattern resembled adaptation, a feedback loop balancing energy and release. The term was controversial, poetic rather than precise, but it captured the feeling of watching a process behave intelligently without intent. By June 2026, the comet began its long outward journey. It had survived its brush with the sun. Against every expectation, it remained largely intact, trailing fragments like memories. Its brightness began to fade, its tail thinning as radiation pressure dispersed the dust. The firehose was closing. From observatories, images showed a faint arc moving away from the ecliptic plane. To the untrained eye, nothing special. To those who had spent 2 years tracking it, that arc meant completion. The comet had entered the inner system, broken its own rules, taught us something about resilience, and was now leaving. In late summer, a final coordinated observation run captured it simultaneously with Hubble, JWST, and several ground telescopes. The combined mosaic showed a ghostly smear across black space. No detail, only presence. Then it was gone, too faint to measure. The data archive was enormous. Terabytes of numbers, spectra, and images waiting for interpretation. But for the people who had watched it night after night, the conclusion required no analysis. They had seen persistence shaped by physics, not intention. They had seen endurance without will. The comet was leaving, but the silence it left behind carried meaning. It reminded humanity of its place, small, observant, temporary, yet capable of witnessing events that began before its existence. In that quiet recognition, there was something like peace. By the autumn of 2026, 3i Atlas was already growing faint. The green halo that once spread wide around its nucleus thinned into a pale whisper. For casual observers, it vanished from sight. For the small network of astronomers who had followed it for nearly 2 years, it remained an unfinished sentence. Every night, instruments searched the coordinates where the comet should be. Sometimes it appeared as a single dim pixel, sometimes not at all. But when it did appear, it still pulsed. Weak, erratic, but there. The last confirmed water emission came in late August. Even then, the plume refused to vanish completely. At a distance where the sun should no longer reach, faint traces of vapour still escaped. The numbers were almost zero, yet never quite. It was as though 3 Thule, my Atlas, was reluctant to stop breathing. The scientific papers began to close their analyses. Each contained more questions than answers. The most complete models could explain partial behaviour, rotation, thermal lag, fracture mechanics, but none reproduced the entire pattern. A few authors admitted the possibility that our assumptions about how ice behaves after billions of years in deep space might be wrong. Perhaps matter itself changes when isolated that long, its structure warped by radiation and cosmic dust. If true, 3i Atlas was not merely a comet. It was an archive of altered chemistry. In September, JWST attempted one final observation. The data were nearly invisible above background noise, yet the spectrum showed a narrow band of infrared light. It suggested something unexpected, traces of ammonia. No comet from another star had ever shown it so clearly. Ammonia is fragile. It should have been destroyed by cosmic rays during billions of years of travel. Its survival hinted at shielding, a dense crust or layered shell that protected it across time. That possibility alone warranted years of study. Back on Earth, the scientists who had dedicated their nights to the object began to feel its absence. They spoke of it less in conferences and more in conversations. One described the experience like watching a ship disappear beyond the horizon. Another called it an experiment in patience. A third said it had changed her sense of distance forever. Even after it faded, 3i Atlas remained on every observing schedule as a line of coordinates. It had become part of the sky's vocabulary. Students learning orbital mechanics traced its hyperbola across simulated charts, seeing in that curve the outline of motion without return. The line did not end, it simply left the frame. By November, the comet was beyond the orbit of Jupiter again. The sun's influence weakened to a fraction of what it had been at perihelion. The jets were gone, the tail dispersed, but the nucleus persisted as a black fragment drifting outward. Telescopes recorded nothing more than reflected starlight, yet even that silence contained data, its fade rate, its trajectory, its refusal to vanish completely. For researchers, the loss marked the end of the most detailed campaign ever mounted for an interstellar object. For the rest of the world, it barely registered. Attention had shifted to nearer problems, closer mysteries, but a few people still checked the coordinates out of habit, as if confirming that the visitor was still on its way. Late that year, a summary paper was published compiling every known observation. The conclusion was cautious, a list of verified facts followed by a longer list of unknowns. Among the verified facts, the comet's speed, composition, and persistent activity. Among the unknowns, the cause of that activity, the internal temperature, and the reason water survived so far from any heat source. The final sentence read, "The behavior of 3i Atlas suggests mechanisms not yet understood in current cometary physics." That was the scientific way of admitting astonishment. Outside academia, the object lived on as metaphor. Writers compared its solitary journey to exile and endurance. Filmmakers used its path as a backdrop for quiet stories about isolation. An ambient musician released an album titled 40 kilograms per second. The tracks used real telemetry data converted into sound. Listeners described it as both lonely and calm, a rhythm echoing through silence. For those who had studied it firsthand, the fascination never faded. They continued to model its motion through the galaxy, projecting its course across thousands of years. The numbers said that by 2080, it would pass within a few light days of another star, a red dwarf without known planets. After that, its path would vanish into uncertainty. Whether it would ever encounter another sun was irrelevant. It had already fulfilled a purpose simply by being seen. The data it left behind remained in archives, terabytes of spectra, images, and simulations. Future astronomers will revisit them with better tools, finding new layers of meaning in old light. But the moment of encounter, our brief intersection with its long voyage, will remain singular. For humanity, 3i Atlas was both proof and reminder. Proof that matter travels between stars, reminder that not all travellers have destinations. In the final observation logs, a short note stands alone. Object departing, signal weak, end of campaign. Nothing dramatic, just a closing entry written in quiet language. Behind that sentence lies the essence of the entire event: observation, acknowledgement, and acceptance. Because even as 3i Atlas fades into the outer dark, it continues the one act that defines all existence. It moves. After its departure, the silence felt physical. Instruments that once filled with data now returned empty lines. The orbit was known, the measurements complete, but the sense of contact lingered. Scientists found themselves checking the coordinates anyway, knowing nothing would appear. It was a habit born of curiosity and of loss. For 2 years they had followed a moving point that refused to behave like anything familiar. Now that point was gone. Only the questions remained. A few research groups continued to model its trajectory through the galaxy. Each simulation projected it moving away from the sun, past the outer planets, through the Oort cloud, and then into the thin boundary where the solar system gives way to interstellar space. There the solar wind fades, and cosmic rays dominate. For a human mind, that distance is difficult to hold. The numbers are too large, the time too slow. At its current speed, 3i Atlas would need almost 10,000 years to leave the gravitational influence of the Sun entirely. In cosmic terms, that is an instant. In human terms, eternity. The models showed that as it travels, the comet will continue to lose atoms. The Sun's last photons will scatter off its dust, then even that faint light will fade. Eventually it will become dark to every telescope, indistinguishable from the cold debris between stars. Yet invisibility is not the same as disappearance. The object will persist, moving through the medium that connects all suns, a thin gas of hydrogen, plasma, and ancient dust that fills the galaxy. In that medium, its surface will erode molecule by molecule until nothing remains but a slow cloud, spread across light years. Some astronomers spoke of that cloud as a kind of message. It will carry atoms that once belonged to another world, and now will mix with the outskirts of ours. Perhaps in some distant age, those atoms will fall into a new system and become part of another planet. In that sense, 3i Atlas is both traveller and seed. Others resisted such poetry. They preferred to think of it as a sample of probability, evidence that matter wanders. Yet even the most disciplined among them could not avoid the pull of metaphor. To witness a body born around another star and then to see it cross ours is to see connection on a scale beyond intention. The galaxy, once imagined as a vast collection of separate systems, begins to look like a single ocean in which small fragments drift forever. The question that follows is natural. If fragments of rock and ice can move between stars, can life? Scientists are careful with that idea. The term panspermia carries both fascination and controversy, but the chemistry of 3i Atlas kept the debate alive. The detection of formaldehyde, ammonia, and complex carbon chains implies that prebiotic molecules survive interstellar exposure. The comet carried not life, but the potential for life, the raw instructions written in atoms. That knowledge changed the tone of the discussion. The universe no longer seemed indifferent. It seemed fertile. In quiet offices, researchers examined spectra again, searching for faint signals they might have missed. Some believed they saw traces of hydrogen cyanide, others methane in ratios too subtle to confirm. Each result suggested complexity deeper than expected. Every discovery extended the mystery instead of closing it. Outside of science, the comet entered language. Writers began using it as a metaphor for persistence, migration, or memory. In classrooms, teachers described it as the story of how far something can travel simply by following physics. For a generation raised on constant noise, 3i Atlas became a symbol of quiet endurance, a story with no conflict, no climax, only motion. Among astronomers, the fascination took a different shape. They began to imagine what the comet was passing through now, the emptiness beyond the heliosphere, a region filled with slow cosmic winds and scattered magnetic fields. The temperature there is barely above absolute zero. No sound, no light, only charged particles moving at unimaginable distance from one another. In that void, the nucleus of 3i Atlas continues its drift, a small piece of frozen memory surrounded by the noise of creation. Somewhere in that darkness, cosmic rays strike its surface, breaking molecules apart. Each impact changes it slightly, erasing details of its origin while spreading its material outward. Over millions of years, the process will blur the boundary between object and environment until they are one. Yet this erasure is not loss, it is integration. The comet will join the background that once shaped it. From Earth, we will never see that process. We can only imagine it, projecting our own sense of time onto a journey that will outlast our species. Even the instruments that recorded its existence will eventually decay. But the data they captured ensures that for as long as language endures, 3i Atlas will remain real, a small dot of defiance against oblivion. Philosophers of science have long said that astronomy is the study of our own ignorance, measured at scale. The story of this comet proves it. We understand the numbers but not the meaning. We know what happens but not why. Still, we look. We point mirrors at the sky and wait for light that has travelled for ages, trying to see ourselves reflected in it. 3i Atlas gave us that reflection. In its slow movement we saw endurance, in its silence, patience, in its indifference, a strange kind of grace. There are no endings in astronomy, only transitions, from bright to faint, from measured to lost, from known to imagined. As 3I Atlas fades into the interstellar sea, it carries more than dust and ice. It carries the echo of human curiosity, the record of a brief alignment between a wandering fragment and a species that noticed. Somewhere far from every orbit it continues without witness, and that perhaps is the purest form of existence, motion without audience, meaning without intent, continuity without memory. When an object leaves the solar system, it does not vanish. It enters a region without boundaries, where direction loses its reference. The sun becomes one star among billions, another light behind the comet instead of before it. For 3I Atlas, this is the beginning of the longest chapter, a movement without end. The numbers are simple. At its current speed, the comet travels almost 25 kilometers each second. That pace will never slow. Over the next 10,000 years, it will pass beyond the heliopause into the interstellar medium. There, the particles of the solar wind fade into a sea of neutral hydrogen. Radiation comes from all sides. Gravity flattens into balance. The comet will not feel the transition, but the distinction matters to us. Inside the heliosphere, it belonged to the sun. Beyond it, it belongs to the galaxy. Every atom that leaves its surface joins that sea. Water becomes gas, dust becomes plasma, and slowly, the shape that once defined the comet begins to blur. The object becomes less a thing and more a process. Over millions of years, collisions with cosmic rays will strip away its layers, erasing structure until what remains is an invisible mist. But even mist has weight, and that weight will move forever. In human imagination, that idea is both humbling and comforting. We are used to endings. Comets remind us that nature prefers continuities. The universe does not destroy, it transforms. Each molecule freed from the surface of 3I Atlas becomes part of the background that shaped it, completing a cycle longer than memory. Future astronomers, long after our civilization fades, may detect another interstellar object entering some other system. They will name it, study it, and wonder where it came from. One of them may be following atoms that once belonged to this comet. There will be no way to know, but the possibility will be real. The act of imagining such futures gives meaning to the present. Science often begins as imagination disciplined by evidence. The discovery of 3I Atlas widened that imagination. Before it, interstellar comets were theories. After it, they became part of the pattern of reality. The galaxy revealed itself as porous, its systems connected by slow exchanges of matter. Space stopped being isolation and became relationship. That realization carried emotional weight even among scientists trained to resist sentiment. They saw in the comet's persistence a mirror of their own labour, years of patient observation, repetition, and small progress. To follow an object for 2 years knowing it would never return is an act of faith in continuity itself. The work does not end with results. It continues in the next generation that asks new questions of the same data. In that way, knowledge imitates the comet, slow, enduring, always leaving something behind. Some researchers spoke privately of the experience as spiritual, though they used other words. They described a feeling of connection, not to the object itself, but to the scale it represented. To look at 3I Atlas was to face an unmeasurable vastness, and still find peace in the act of looking. That quiet acceptance is rare in science, where answers are currency. Here, the absence of closure became the gift. Far beyond the sun's reach, the comet continues through the magnetic tides of the galaxy. It passes through clouds of gas thinner than any vacuum we can make, each molecule separated by kilometers. Occasionally, a dust grain collides with its surface, creating a spark of heat too faint to see. Those sparks are its heartbeat now, one every few years, measured across infinite dark. Somewhere in its frozen interior, isotopes decay. The process is unimaginably slow, yet it never stops. Energy radiates outward at a rate so small it cannot change the orbit, but large enough to mark the passage of time. These silent decays are the clock of the object, a measure of existence that requires no witness. If we could see it from afar, 3I Atlas would look like nothing. A body smaller than a city, blacker than soot, drifting against a field of stars. No light reflects from its surface anymore. Only when it crosses between us and a distant star would it reveal itself as a brief dimming, a shadow across light. That shadow would be enough to prove it still exists. On Earth, centuries will pass, languages will change, continents will shift, technology will evolve, and eventually the story of the comet will become a record read by few. But the motion it began will continue, indifferent to the fate of those who first measured it. In the end, its journey outlasts ours. This is the paradox at the heart of astronomy. The more we understand, the smaller we feel, yet the more connected we become. The discovery of 3I Atlas reminded humanity that insignificance and meaning can coexist. We are small, but we notice. We vanish, but we record. The comet showed that observation itself is an act of participation, a way of joining the motion of the universe. Somewhere between the stars, the object still spins. Every rotation, every fragment that falls away, becomes part of the great exchange that binds galaxies together. It is alone, but never isolated. Nothing in space truly is. Even silence connects. Even absence communicates. When we look toward that region of the sky where 3I Atlas has gone, we see nothing, and that nothing is full. It contains the memory of a comet that defied cold, of the instruments that saw it, of the hands that built those instruments, and of the minds that wondered why a frozen rock would act as if it were alive. The answer may never come, but the question will remain, carried forward like the comet itself. Long after our light fades, 3I Atlas will continue its drift, a silent witness to the idea that existence requires no purpose beyond persistence. At some point, the distance becomes more than a number. It becomes a condition. 3I Atlas has long since crossed the heliopause. The wind of our sun no longer reaches it. The object moves now through the interstellar field, cold, thin, infinite. Every direction looks the same. There is no sunrise, no orbit, no return. There is only motion and the slow erosion of identity. We know the equations that describe this phase. We can calculate its speed, its decay rate, the faint drag of dust against its surface. What we cannot calculate is presence. The comet exists where our instruments cannot reach. All that remains of it here is memory, datasets, images, coordinates, numbers stored in archives, resting quietly until someone opens them again. In those numbers, the story continues. The scientists who once watched the comet have turned to other tasks. Yet each of them carries a moment that belongs to 3I Atlas, a graph traced by hand, a first detection on a monitor, the instant realization that they were witnessing something older than the Earth itself. That feeling, small and wordless, lingers longer than data. It reminds them why they began watching the sky. Every generation of astronomers inherits such moments. A flare, a signal, a faint point of light. Always something almost lost to darkness. The details change, the impulse does not. The act of looking outward is also the act of returning inward. It reveals the structure of our need to know. 3I Atlas has become part of that lineage. It joins the list of things we once thought impossible and then recorded carefully. Its trajectory is now a lesson in humility written across time. When students study celestial mechanics, they trace its hyperbolic path and learn how gravity shapes everything except curiosity. Curiosity obeys no orbit. It escapes as easily as the comet did. If the object could be seen now, it would appear unchanged, drifting between fields of dust and scattered gas, surrounded by nothing that could name it. It moves through silence so complete that even radiation arrives one particle at a time. Each collision of a cosmic ray with its surface is a whisper of contact, a soundless confirmation that interaction continues. Somewhere in that dark, its rotation still persists. The 9-hour cycle that began before life on Earth continues without interruption. That spin is its memory, a rhythm carved into ice and rock, repeating without audience. It does not matter whether anyone knows. The universe remembers through motion. Back on Earth, the story of 3I Atlas is taught as an example of observation and patience. The data it provided redefined how scientists think about frozen chemistry and interstellar migration. Yet those who speak about it now rarely mention the emotions that accompanied the discovery. They speak of flux ratios and spectral lines, not of awe. But awe was always there, unspoken, between the sentences. Over time, the comet has become a kind of meditation. Its path reminds us that meaning does not depend on permanence. Things can fade and still be significant. We measure, we learn, and then we let go. That rhythm, attention followed by release, is the heartbeat of science itself. The same rhythm exists in the universe. Stars ignite, burn, and die. Planets form and vanish. Light travels until absorbed. Every process ends by giving itself back to the system that produced it. 3. Atlas follows that same rule. It will continue dissolving grain by grain until it is indistinguishable from the space around it. Nothing will remain to mark its passage except the changes it caused in those who observed it. For a long time, people will still speak its name. Then, like all names, it will drift out of language. What will endure is the awareness that such a thing once existed. That awareness will live quietly in the margins of textbooks, in the data stored in long-forgotten archives, in the soft curiosity that leads someone someday to look again into the dark and wonder what might be moving there. Perhaps another interstellar visitor will come. It will receive a new name, a new designation, and the same patient attention. Humanity will repeat the ritual of measurement and meaning, and somewhere far away the atoms of Defied Atlas will continue to move, part of the same endless circulation. In that thought lies the calm conclusion of this story. Nothing truly ends. Everything continues. The comet's water became vapor, its dust became light. Its motion became a reminder that the universe is a single process unfolding slowly. We are part of that process, briefly conscious, briefly aware, sharing the same drift. Far beyond our reach, the traveller from another sun moves through silence. It leaves no trail now, no heat, no reflection. Only the certainty that it exists. In that certainty there is peace, the same peace found in stillness after discovery, in the moment when curiosity settles into understanding. The same peace that fills the sky when observation ends and wonder remains. Time passes, and the world forgets its visitors. The headlines that once carried the name of Defied Atlas have long been replaced by other stories. New discoveries fill the feeds, new comets cross the sky. New questions rise to replace the old. Yet somewhere in the background of astronomy the numbers remain. They live in tables, graphs, and archived observations, silent but enduring. Data does not age the way memory does. A century from now, when the last of those who witnessed the comet are gone, the record will still exist. A researcher studying orbital mechanics will open a digital file and find a curve labelled 3I Atlas 2025-2026. The file will look ordinary. Columns of numbers, units, coordinates. But in those numbers lies a fragment of history. The student will know that those figures describe a real object that once passed through our sky. In that moment the comet will live again, not as light, but as understanding. This is how astronomy preserves what it loves. Not through possession, but through translation. Light becomes data, data becomes knowledge, and knowledge becomes continuity. The act of observation turns impermanence into permanence. It does not prevent loss, it gives loss a shape. In some small archive room, light from the past waits patiently for new eyes. The students who find it will read descriptions of the Firehose phase, the unexpected venting, the green coma. They will compare the notes to newer discoveries and realize how much has changed and how much has not. They will see that the questions remain the same. What causes persistence? What defines silence? What holds structure against decay? Perhaps one of them will stand outside after midnight, remembering those questions. They will look toward the constellation of Crux, tracing the direction where the comet once went. There will be nothing visible, only a depth of black that seems to absorb thought. Yet knowing that a traveller from another sun once passed that way will alter the darkness. It will no longer feel empty. It will feel inhabited by memory. For most of human history, the night sky was a mirror of belief. People saw stories, gods, and omens in its patterns. Modern science replaced myth with measurement, yet the impulse behind both remains the same. We look upward to understand what cannot be seen directly. The discovery of 3I Atlas joined those two traditions. It was both data and parable, a demonstration that mystery and measurement are not opposites, but companions. Somewhere far beyond the outer planets, the comet continues. It no longer vents, no longer shines, but its atoms are still in motion. They will remain in motion until they join another current of dust and light. In that sense, it has not ended. It has changed form, as all things do. The same is true for us. The observers who named it, measured it, and wrote its story will dissolve into their own continuities. Their atoms will return to the same universe that carried the comet. Their curiosity will persist in others. Their wonder will echo in the next question asked, in the next observation made, in the next faint signal noticed and recorded. This is the quiet truth that 3i Atlas left behind. Everything drifts, but nothing drifts alone. Every object, every mind, every piece of light participates in a shared movement that has no centre and no end. To know this is not despair, it is balance. The same balance that keeps planets in orbit. The same rhythm that turns chaos into pattern. The same stillness that lives beneath change. If someone in some distant future could stand on another world and look back toward our sun, they would see nothing unusual. The star would shine as it always has, yet somewhere in that light would be a few scattered atoms once belonging to the comet that passed us long ago. Those atoms would reflect the new star's light just as they once reflected ours. The cycle would be complete without anyone to witness it. Back on Earth, the story remains in words. This too is a form of orbit, a loop between discovery and remembrance. The voice that tells it now is only another observer, translating numbers into quiet. The listener becomes the next watcher, the next point in the chain of awareness. Through this simple exchange, 3i Atlas continues to exist. And so the narration slows, not to end, but to align with the object it describes. Both move towards silence. Both continue into the same horizon where distance becomes calm. The comet drifts. The voice fades. The stars remain. The story of 3i Atlas has ended for the instruments, but not for the idea. What began as a data point now exists as perspective. The numbers remain in databases, unchanged, but their meaning expands every time someone recalls them. That is how discovery survives. Not through repetition, but through inheritance. One generation measures, another imagines, and both keep the motion alive. In the quiet years that follow, astronomers move on to new missions. Some study planetary atmospheres, some search for exoplanets hidden in shadows, some analyze signals from distant galaxies. Yet whenever a new interstellar object appears, the first comparison is always to Atlas. The question repeats, will it behave the same way or differently? That question itself is proof that the comet never truly left. It became a reference point in the human record, a calibration of wonder. Each time a telescope gathers light from a new source, part of that light passes through the dust left behind by earlier travellers. Somewhere among those grains are atoms once released by Atlas. The idea that observation and object could be joined so literally gives science a strange tenderness. We are not apart from what we study. We are connected to it through the material we share. In classrooms, professors still mention the Firehose anomaly. They describe the impossible water jet that defied temperature and distance. Students take notes, unaware that the event they study once felt immediate to those who watched it. For them, it is already history. That is the natural motion of a knowledge. Information cools into understanding, then becomes part of the landscape, solid enough for new questions to stand on. Somewhere in that landscape lies the deeper lesson. 3i Atlas taught us that certainty is temporary. Every equation that explains a phenomenon eventually meets a case that resists it. This resistance is not failure, it is evolution. The limits of explanation are the starting points for new insight. The comet reminded science of its own humility. It whispered through data and silence that nature will always keep one secret in reserve. Outside the field of research, the name lives on quietly. Poets still use it to describe solitude, painters still use its path as a curve of composition, and composers still borrow its rhythm. The slow rise, the steady pulse, the long fade. Its presence lingers in the culture of curiosity. Each time someone watches frost melt on glass or steam curl into air, they reenact the same pattern that Atlas performed in space. Transition without destruction. For humanity, that recognition is valuable. It shifts meaning from control to coexistence. The object that refused to stay frozen teaches the observer that persistence is not opposition. It is adaptation. Everything changes, but the continuity of change is what holds the universe together. The same principle that let a comet breathe water in the dark allows stars to shine, planets to orbit, and consciousness to emerge long enough to notice. Centuries from now, when even our instruments are relics, the motion of 3 I Atlas will continue beyond calculation. Its particles will have scattered across light years, absorbed into nebulae, recombined into new forms. Some fraction of its atoms will fall into a newborn star. Some will join a disk of dust and ice around that star, becoming part of another comet, another beginning. If any future observers there measure a strange jet of vapour in the cold, they will wonder about its cause and give it a new name. The pattern will repeat as it always does. The universe keeps its own continuity. Observation is our way of participating in it. We record what we see, we describe what we feel, and through that act we extend existence beyond the moment. The trail of Atlas may vanish, but the awareness it created remains, not visible, but present, like background radiation that never fades completely. Every story that science tells ends the same way, with silence, not the silence of absence, but of completion. When all the data are gathered and the analysis ends, what remains is quiet. That quiet is the sound of understanding settling into being. The comet has left. The knowledge stays. Both are forms of persistence, and both are enough. So the narration slows. The voice turns toward the same horizon the comet followed, into a distance that is not empty but endless. Somewhere out there, the fragments of Atlas continue their drift, scattered yet unified by motion. They pass through fields of dust, through the invisible geometry of gravity, through the thin hum of starlight. And as they move, they carry us with them, not our bodies, not our instruments, but the trace of our attention, the proof that we once looked outward and found beauty in a thing that should not have existed. That is where the story ends, not in disappearance, but in recognition. The comet, the observers, the listener, all parts of the same long pattern. The pattern continues calm and complete, across space, across time, across silence. And so, the voice fades, the stars remain, the drift continues. When all the words have been spoken and all the data recorded, what remains is the image of distance. The comet has long vanished beyond every lens, but its path endures as a thin thread woven into the background of our understanding. Each generation adds its own thread, each discovery another line of light. In this way, knowledge becomes a tapestry built from motion. 3II Atlas was one thread among billions, a single spark that crossed our sky for less than 2 years, yet its presence changed how we see the quiet between stars. Before it, interstellar comets were a curiosity. After it, they became part of the possible. It proved that systems are not isolated, that even in the cold, matter travels, that the boundaries we draw are illusions of scale. Long after the object itself has scattered into atoms, its influence persists in the way we think. Scientists designing future observatories still mention it in proposals. They reference the anomaly, the impossible venting, the steady rhythm that broke every rule. Each new instrument carries a question traced back to that event. What else is out there that we cannot yet imagine? The question is the legacy. For those who lived through its discovery, memory remains sensory. They recall the glow of monitors in dark rooms, the hum of cooling fans, the quiet exchange of data through shared networks. They remember the sound of doors opening to the night air after long shifts, the first breath of cold outside air mingling with starlight, the awareness that somewhere out there, a traveller from another sun was breathing water into emptiness. It was a small detail in the vast archive of science, yet it felt intimate. That intimacy is what survives when the specifics fade. Facts hold precision, memory holds meaning, together they create continuity. To remember the comet is to remember our own capacity for attention, the rare, deliberate focus that suspends noise long enough for wonder to form. Perhaps that is the real discovery, not the object itself, but the pause it created. For 2 years, across languages and continents, people turned their eyes in the same direction. They shared the same small point of curiosity. In that alignment, humanity experienced a moment of unity, quiet but genuine. The comet was the cause, but the connection was the result. Now that moment belongs to history, yet history is only another orbit, Another repetition of light and loss. Future comets will come, each with its own secrets. They will remind new observers that every mystery is temporary, that every explanation begins as disbelief. When they are gone, they will leave the same peace behind, the calm that follows understanding. The sky above Earth will continue to change, stars will shift, constellations will distort, and our descendants will give them new names. But the principle that guided those who watched through the atlas will remain unchanged. To look outward is to know inwardly that we are part of what we see. The act of observation unites observer and observed. There is no distance in that exchange, only reflection. Somewhere, light from our sun still touches the trail of dust the comet left behind. The grains glint for an instant, then drift on. Each one carries the signature of two stars, the one that formed it and the one that briefly warmed it. That brief contact between systems is the essence of cosmic time. Moments stacked across eternity, each containing all others. Eventually even those grains will disperse. They will merge with the interstellar medium, mix with the raw material of new worlds, and continue the cycle. The universe wastes nothing. Every particle serves again. The journey of 3i Atlas will never end because the universe itself does not end. It only changes form. And so we return to silence, the same silence from which the story began. The telescopes rest, the instruments cool, the sky above remains patient, unaltered by attention. Somewhere within that silence, countless other travellers move unseen, each carrying a fragment of history toward places where history has not yet begun. They will pass through new skies, under new eyes, continuing the same conversation between matter and mind. The lesson of 3i Atlas is simple and final. Motion is the universe's language. Everything speaks it, from atoms to galaxies. We heard a single sentence of that language and called it a discovery. But the sentence continues, endless, without punctuation. The object is gone, yet its rhythm remains. Slow, even, eternal. The same rhythm that turns planets, that carries light, that ends this narration. The voice falls quiet, the stars hold their positions, the drift continues.